This is Algebra 1, Term 2, Lesson 13, and we are going to be working through some real-life systems of linear equations. The first activity is Desmos, and we're going to address the Oreo cookie, and then a series of activities all in your slides. So let's start in Desmos. So the Desmos activity is called Cookie Questions. It says 30 to 45 minutes, maybe a little longer because I did add some things and take some things out. So this entire lesson I have scheduled for 2 to 3 days because kids are doing bigger applications. This will actually be one of the shorter pieces probably, but I wouldn't shortcut any of this. This is pretty important things they're doing. They are going to be writing and solving a system, and then making sense of algebraic methods. So first we have the Oreo cookie, and this is just an opinion question. Which do you like these cookies? And if not, yes, no, or it's complicated, and then they can explain their answer if they want to. And then here is a double stuffed Oreo. Just what do you notice? What do you wonder? So we're just trying to draw kids into the activity. And here they're going to try to predict what do you think the question will be. Now for this assignment, if you're doing this activity, super important that you pace your students. You don't want them looking ahead because they'll see things that will influence their answers or will give them the answers, so you don't want them to see that. I do have quite a bit of notes typed in your teacher moves, and there are some sample responses, so please take a look at those. So here's one question, and this is the one question that will be addressed in the activity. What is one single wafer? What are the calories in one single wafer? Not the top and bottom of the cookie, but just the top of the cookie, or one single layer of cream. What is your prediction? So they're going to predict what they think it is. And then here they're going to write equations, and we're not using X and Y, we're using W and C. W for wafer and C for the cream filling. And they have two different equations, one for regular and one for double stuff. And then we're going to have two different stacks, and this is the one they're going to actually write and solve a system for. So they'll first just type some things that they may notice about this system. And then now it's separated. What do you notice now that it's been taken apart? And then finally they're going to write two equations. Now I've given them some information, the total calories in the regular Oreos, which is the stack on the left, and the total calories for the double stuff, and that's the stack on the right, and they are to write two equations here. So again, pace your students, don't let them look ahead, and take your time. The goal here is to get kids to write these equations without us. So if you are showing them this answer without them ever coming up with it, they're probably not learning it. So it's one of those things they have to kind of fumble through these on their own a few times, even quite a few times, to really grasp where things are coming from and how to do this. So take your time on this part of the assignment as they are writing these equations. Help them make sense of them. One thing I sometimes do with students is to have whiteboards and have them write the equation and then label each little part of it. Like, what does this W stand for? What does this C? What's this number in front of this W? What is this? What does it mean? And have them label the words on their equations to make sense of them. And you can even insert. The kids have the option of uploading images for this, so they could delete this text and they could upload their image of their equation with all that stuff written on there in this box. So it's a way of them giving you way more in a different way. Now when they get to this one, they're supposed to solve their system. So whatever they wrote on slide 8, by this time you probably need to make sure they're all correct before they go on to slide 9. So keep them there. Let's get everybody on the same page. Another thing I've done is I've added a drawing here. So this is the same picture, and I want them to write on here. They can use the pen tool, the line tool, the equation, the text, and they do need to tell me, what's one wafer going to be. So they could like point to the wafer and go, the wafer is, and here's the filling, but not this filling, this filling. You could even point to the fact that the double stuff, which is the one on the right, has two fillings. So it's would be double the calories because it's got 2 of them. Anyway, get the solution. What is the solution reveal in context? So be sure to encourage them to use specific words, not just numbers, to explain what that's meaning, and then explain or show their process. So that's where they can upload a whiteboard image if they would like, and they could type in math type explaining the steps. So they have choices there. All right, the last slide. I don't really want to zoom in too close on this because this reveals the answers, so I'll have this blurred out for you. But do notice there are 3 methods here, and I have used a variety of strategies, and all of them are a little different than your typical textbook strategies. So 2 of them involve linear combinations, and 1 involves some method of substitution. And I'm having them examine all 3 methods, and then they're going to choose the method that they prefer out of the 3. If they had to pick one, which one would they pick and why? And they can tell me one thing they would do differently in that method. If they didn't like any of them, maybe they've got one that's a little better, what would they change to make it even better? And again, we're choosing from algebraic methods, not graphing. So I know graphing is the go-to because it's super easy with the Desmos calculator, but there are times we will need to solve algebraically and do things algebraically. So we have to kind of trudge through this part. It's not much fun for some kids, but anyway, have them examine these methods, choose a method, and that concludes our Desmos activity. So we're going to go back to the slides and take a look at some other questions. So the first question in the slides is about a field trip. So the difference in these is I don't give them the questions. I have them formulate the questions. But you may want to keep in mind we want the kids to write and solve a system of linear equations. And if they're not getting anywhere close to getting that in their question, then they might need to consider, let's answer a different question. Like, why is that color of that sign that way? I mean, that's not something related to the task at hand. So we need some mathematics here. All right, so one group of 12 students and 3 teachers paid this much. Another group, what is the question? Now, I do have them go further than just solving a system. I do have them question whether, is this fair? Is this payment plan fair? Is this not fair? So we're going to do a little more than just solve systems. And here's what some things I put down here. What are the 2 variables? What is the domain? What is the range? What do we know about our data? So we're going to ask all that. But what you could also include here is this a fair payment plan? Or do you think it should be different? Explain. So add those types of questions in here to encourage dialogue about the scenario, because that's something I want them to do beyond just solving a system. Let's make sense of this. Is this a reasonable answer? Would you expect to pay that? Is it too high? Is it too low? What might be going on? All right, the next one is going to be a cash box question. They have 16 bills worth exactly $200 in a cash box. There's only 10s and 20s in the box. What's the question? What do you know? So the question at the bottom I put on all the initial slides would be what information might be helpful that isn't already stated. What is something else we would need to know about this scenario? And then I've asked the same questions here at the bottom that I asked before, but you could also include, is it reasonable to know exactly how much money is in a cash box and to know that there's only 10s and 20s? I mean, I don't know. I guess you could know that. All right, and then we're going to go ahead and look at the fence. This is a building fence. The length of the pasture is 3 times the width, and the perimeter is 240. What is the question? Now, here we are making some assumptions. A big assumption here is that this field is actually rectangular. What would change if it wasn't a rectangle? How would we even go about this? So that's you could really extend this and go into a much longer task. I am going to work this, and I'll give you some suggestions in your teacher slides about how to handle this if you do want to extend it. but I'm still giving them the same questions. What are the variables in this situation? So variables are things that change. And what is the domain in the situation? So it kind of depends on which way you write your function. Is x going to be a function of y or y a function of x, or how's that going to work? What representations might be helpful? Tables, graphs, equations, and words. And what do we know about this graph? Something that will surprise these kids is they will expect things to increase that decrease. They'll make sense of it once they graph it. But I would have you, even if they do solve these systems by writing and solving the system and do it algebraically, I would encourage you to graph it and have conversations about why is this graph decreasing, because it doesn't intuitively feel that way when you read these questions, but most of these are decreasing graphs. All right, this bug collection is the last task, and it's a bug collection contains 6 insects with 6 legs and other species of bugs with 8 legs. And the collection has 75 bugs with a total of 526 legs. Here's one of these textbook questions that you scratch your head and say, wait a minute, who counts bug legs? So I put that in here. I want you to have that conversation with your kids because they are presented with tasks like this every year in school, and they need to have the ability to just speak about that, because that is a frustration lots of students have. I have it. Why are we even doing this? Is this even plausible? Who counts bug legs? Okay, just for the sake of argument, we're going to say somebody actually did this and go ahead and solve this question. But give your kids an opportunity to vent and answer that question in their speaker notes at the bottom. These little questions down here are not just there for looks. I really do want them to type in answers to that. Is this plausible, and who counts bug legs? And then down here on the next slide, we've got a bug collection that contains insects. Same problem. Answer this question with your team. So I have set every single one of these tasks up as a team task. They would insert pictures, solutions, and strategies. Now the domain in this situation, you can be as specific or as general as you want with that answer, but you would probably want to talk about it with your students. In most of these cases, the domain is going to be integers. Like in this case, you do not have fractions of bugs, fractions of legs, at least we hope not. So you don't need to necessarily put an inequality on this. You might say positive integers, so they could even just use a phrase for that instead of putting out a formal inequality or a notation like that. So just something to consider. The domain would be the types of numbers we would input into our equation, usually just for your independent variable, but actually it's going to kind of go for both, I guess, in most of these. All right, the last task in this activity is a doing business. And there's 3 slides because there's 3 parts, and they're going to work all the parts and put 1 part on each slide. Now, I would probably recommend they do this one not as a team, just to see where individual students stand. But of course, they're probably going to ask and answer questions of their teammates, and that's fine. All right, let's take a look at this doing business activity at GeoGebra. Now at the top of the activity, we are given the basic instructions about what this graph is representing. The coordinate system represents the number of products, Y, that a business markets X hours after the initial launch. So you may talk about that as a class before they get started. Launch would be the beginning, like when this business first opened the doors and began doing work. And this is hours, not days, but hours after their first launch. And then these are the 3 parts. Explain why the model for business A is partially solid and partially dotted. Now the model they're referring to is this graph. And you can have a discussion about models. What are models? Things like graphs, tables, equations. State the domain as an inequality, and then I do tell them they don't need to do interval notation. I actually teach that in Algebra 2. I do not teach it in Algebra 1. That's kind of up to you though. If it is something you teach, you could leave that in there. But I did put this note in the student slides that says you only need to give the domain as an inequality, so they would not have to do that. State the value of the y-intercept and interpret its meaning. So they're going to click here and get that value, and they're going to read this statement up here and try to make sense of it. These labels are missing, so that makes it harder to kind of keep track of what's what. They could take a screenshot of this and put the labels on there. I would recommend that, and then start answering some of these questions. All right, once they've answered part A, they're going to go, or part 1, they're going to go on to part 2. Here it says adjust the graph to fit the criteria. So it does say in part 2, graph the model for business B so that B has a higher number of products initially and B markets products more slowly. So it starts out with more products initially, but it's growing more slowly. So here's B, and it's not going to be correct. I mean, what they've got in here is not doing what that says. So they need to adjust this graph by dragging these points up or down. They can drag this up or down. They will be writing equations later, so it's to their advantage to keep the numbers nice, but you know, they can do whatever they want. All right, and in C, it's giving you some information about that. They need to adjust this, and they'll need to adjust this to make C do what it says. So I'm not going to show it to you, but that's how they fix 5 and 6. And once they get that, they're going to screen capture all the points of intersection. They need to make sure that they have these points. They're not going to be able to show them in here, I don't think, but what they could do is if they take a picture of it, the kids could kind of lay over it maybe some points. I don't know. You might ask them about that, if y'all have the capability of them drawing on their pictures. I often use Paint to do everything because I'm on a desktop, but you can open a Google drawing and then they can put this picture in there and label it. So they could find out what is this point and what does that mean. If they're not able to label it, then they could just type the point into their work, type it on their slide, and tell me what it means. That would work as well. All right, and then part C, it says use the adjusted graphs from slide 11. So that's the ones they just did, and answer these questions. They're going to type their equations and put the equations on this slide. So they may use Desmos, math.new. They could even use GeoGebra. GeoGebra has a calculator, so I don't know if you've been there or not, but they could type it in there. I think the prettiest ones are Desmos and then math.new, so it's up to the kids. So that concludes this assignment. Now you're thinking, wow, 2 or 3 days, really? Well, here's what I'm thinking. If I were doing these slides with my classes, I probably would split up the class and give classes different things to do. Like I may not even do all the tasks with all the groups. Like team 1, you're going to do field trip. In team 2, you're going to do cash box. In team 3, you're going to build a fence. And you could have them each do their own. But you do at the end want to come together and have them look at all of them. So maybe they will work in depth on one for a whole class period. Like not just answer the question, maybe make a poster. Maybe come up to the whiteboards and let's do some building thinking classroom work on this task. And then you want to come back and you want to answer the question and fill up this slide. This would be a good opportunity to just kind of find out what your kids know, because they're about to have their term exam and we need to go over absolutely everything that we possibly can with these problems. So that's why I gave you such a long period of time. The same is true on your activity in Desmos. That last problem where I gave you those 3 methods for solving, let's go back and I'll show you something else you can do with this. One of the teacher moves I put in here is they can extend this and come up with a 4th algebraic method. And that's really super powerful. When kids have to figure out another method when there's already 3 pretty detailed methods given, give me something else. Which team can come up with a 4th method? You know, and then do it graphically. You could solve this system graphically. You could put that in here. So this can also be extended. The next thing you could do is have them come up with another cookie problem. Let's go out and find a different cookie and use the what we know about cookies. We could use the calorie count to try to break them up and see if we can figure out if this holds true for other types of sandwich cookies like Oreo. Are these numbers the same or different? Anyway, this is a long activity because of the types of work, not necessarily because it's that more challenging, but I do think it's so worth the time that you put into it. These are the type of activities that stick with kids a long time. So try to get as much as you can out of it. So that concludes real life systems. Our last lesson for term number 2 is next time, and then our term exam. Y'all have a great day.